Sorry about that. Once again, a little technical difficulties here. But where we left off, we were talking about the cost of equity and what we calculated in our slideshow here. And I'm not sure the textbook's still the same, but what we calculated in our slideshow is 13.83 for the SML method or the CAPM approach. Using the kind of dividend growth model, we got 10.55. And then if you just average the two, you get 12.9. And textbook clearly came out with different numbers. These are older slides that go with the textbook, so I'm not sure if your contemporary newer textbook still has the same numbers or not. I'm assuming they do. Therefore, you'll see that it kind of comes up with different numbers, but they do the same approach where they average them. And as you can see, the two averages are relatively similar. So the cost of equity, regardless of which approach you're using, what time, still pretty similar for this particular firm. 12.6%, 12.19%, pretty similar. You can do the same thing for the cost of debt. And we're going to kind of go through this a lot quicker. Typically in class, I go through the stock example and dig into how you would obtain all that information. Not so much for bonds. Bond data is more difficult to find, and therefore you need access to certain programs in some cases in order to obtain information. So we're just going to assume a lot of the stuff is current here. So we have some bond information here. We have coupon rates, maturity, face value information, market value information, and then a weighted yield to maturity. Since market values are deemed more relevant, we're going to only use market value weights here. And we're going to use an average yield to maturity. This is all just information that they would be using in order to compute the cost of debt. This is not necessarily relevant at all for your quiz, by the way. So, capital structure weights, you're going to have your equity, which was 72.67 billion, million, times the 52.99 stock price gets you 3.851 billion. Debt was 1.4 billion. The total valuation of the firm, you just add the two. Then you can get weights from each by taking your equity over the total, debt over the total. You get percentages. Looks like this firm's more heavily weighted towards equity. You toss that into your WACC equation, which this is the stock portion, this is the debt portion, and you can tell that the debt portion is a little odd because it has this 1 minus the tax rate over here. And you'd get 10.11%. So that's the way you could actually go about finding the information for the weighted average cost of capital. We're not going to need to do that clearly on a quiz, but it's good to know how to calculate it potentially for a quiz. Definitely, I would think that it would be good for you to know that the generalized formula for the weighted average cost of capital. Text goes on to talk about the risk-adjusted weighted average cost of capital. A firm's WACC reflects the risk of an average project undertaken by the firm. Average is referring to, in terms of risk, the firm's current operations. Different divisions within the firm may have different risks, and I'm sure you guys are all familiar with that. The divisions or projects WACC should be adjusted to reflect appropriate risk and capital structure. So there could be problems if you just use the same weighted. That's what the generalized synopsis of what we're about to talk about. There could be problems if you just use that WACC for every single project across all divisions, because certain divisions are more risky than others and some aren't. There's differences between divisions within a particular firm. All right, so that's what they're about to show you here. So what would happen if we use the WACC for all projects regardless of risk? We assume a WACC of 15%. So we have a bunch of projects here, project A, B, C. Each of them have an IRR associated with them, 17, 18, 12%. And we're making decisions based on the IRR. Our weighted adjusted cost of capital, again, was 15%. So 18 is bigger than 15, 17 is bigger than 15. So you accept those two projects and you reject project C. Here we're assuming once again, the WAC's 15%, adjusting for risk changes with the decision. We already talked about the fact that we looked at the IRR versus the WAC. We made accept decisions based on that. Now, if we were looking at the required return here, it's a little different, right? We have 20%, 15%, and 10%. And here we're showing that when the IRR is greater than the required return, we have an accept. And when the IRR is less than the required return, we have reject. So IRR is greater than the required return.